This video is for section 2.7, Solving Rational Equations. You spent last class learning how to simplify rational expressions, and now we're going to use those same methods along with our other typical algebra methods to solve equations. When you're solving a rational equation, the same rules for solving non-rational equations apply. If I have a plus, I need to subtract to move it to the other side. If I have a minus, I need to add to move it to the other side. I always do the opposite. But we also need to think about how to add and subtract fractions. In order to add and subtract fractions, we must have common denominators. Our common denominators are going to look very different than what you're used to. For example, if I wanted to add 1/3 plus 4/9, I have to make sure that I have common denominators. Well, 9 would be my common denominator because 3 can go into 9. So I'm going to take 1/3 and I need to multiply 3 by 3 to get 9, so I need to multiply both the numerator and the denominator by 3. This gives me 3/9 plus 4/9, and now I can add going across. 3 plus 4 is 7, with my common denominator of 9. This same rule is going to apply as we move forward with rational equations. Let's look at an example. Solve the equation. The first thing you need to do is identify your common denominator. And I always like to write mine separately so I know what I'm looking to work for. So in this case, I have an x and a 3 for denominators. Well, I can't make x into 3 or 3 into x, so 3 times x is my common denominator. So now I'm going to rewrite my equation with that denominator. So if something plus over 3x over 3x over 3x. Well, if I notice, in the first term I have 2 over x. Well, the denominator is missing the 3. So not only do I have to multiply the denominator by 3, but I also have to multiply the numerator by 3. And 2 times 3 is 6. Then I look at the second term. In this case, I have the 3, but I need to multiply both terms by x. So I have 5x on top. And lastly, I need to look at the final term, and it also needs to get multiplied by 3. So 7 times 3 is 21. Now the nice thing about rational expressions is once I have all of my common denominators, I'm going to cancel out the bottom, and it's going to go away. So I'm left with 6 plus 5x equals 21. This is an equation I know how to solve. Go through your opposite operations. You end up with x equals 3. Now I have to go back and make sure that 3 is a possible answer. Is it going to make my denominator 0? No. So 3 is my only answer to my equation. Let's try another one. Here, I have to think about what's happening with my equations and look at factors. X squared minus 1 is factorable. It's going to factor into x plus 1 times x minus 1. And you did this in the last section when you were simplifying these expressions. So my common denominator in this case is x squared minus 1, or x plus 1 times x minus 1. When I rewrite my equation, I know that the first term needs to get multiplied by x minus 1. The second is just fine, but the last term needs to get multiplied by both. So multiply by x squared minus 1, the whole thing. So I end up with the common denominator of x squared minus 1 over x squared minus 1 plus over x squared minus 1. Now the first term, like we said, needs to be multiplied by 3x. So I have 3x times, so 3x times x minus 1 for my first. Second term stays at 12 because it already has both of my factors. And the last two needs to get multiplied by the entire thing. Now I can drop my denominators and back to an algebra problem. 3x times x minus 1 equals 12 plus 2 times x squared minus 1. You need to make sure you start with your distribution. So when I distribute here, I get 3x squared minus 3x equals 12 plus, and I gotta distribute my 2 as well, 2x squared minus 2. Now, you'll see I have x squared terms, so I gotta get everything on the same side and end up setting it equal to 0. So I am going to take away my 2x squared from both sides and take away 2x squared over here. And then 12 minus 2 is 10, so I'm actually going to take away 10 from both sides. And I end up with 0 equals x squared minus 3x minus 10. Well, my question becomes, how do I find my answer now? We actually did this in section 2.4 and 2.3, where you had to find the zeros algebraically. And if you recall, for some of us, if we weren't sure how to factor, what we did was we went to our calculator and we used the factor menu on our calculator in order to factor the function for us. When you factor this function, I get x minus 5 times x plus 2. Well, setting each factor equals to 0 results in x equals 5 and negative 2. And those are my solutions. You have to keep in mind, anytime you see an x squared, anytime I have this x squared term in my answer, I'm going to have to factor my problems in order to figure out what x equals. Let's try another one. Solve the equation. Here, I still need to think about what's my common denominator. And in this case, it's 4 times x plus 3. So both of those guys multiply together. You can skip a couple of steps as you're going through here. For instance, I need to understand, in this first term, the only thing it's missing from my common denominator is the 4. So I'm going to take the top number times 4. The second term is missing the x plus 3. So I'm going to multiply that guy times x plus 3. Then I can jump straight to dumping off my denominator if I want and realize that I have 28 equals x times x plus 3. Now I can start into my algebra. Remember, I need to distribute first. So I get 28 equals x squared plus 3x. I'm going to move my 28 to the other side. And I get 0 equals x squared plus 3x minus 28. Now, I'm ready to factor in order to find my answers. When I factor this equation, I get x plus 7 and x minus 4. So my answers are x equals negative 7 and 4. Let's go on to another example. This is the same example as we had the first time, so we're going to skip it. Now is a good time to pause the video and attempt to do these two questions on your own. When you're finished, come back, restart the video, and check your answers. Here are the solutions to the two student examples. Notice, on the second example, you had to do a lot more distributing. Remember, if you get stuck with your expansion, you can use your calculator for that, as we showed you in class. Alright, let's move on to the next example. Sometimes there's extraneous solutions. Not all solutions that we're going to get are actually possible, because if you recall from our domain discussions, our denominator cannot be 0. So let's go through and solve this example. My common denominator is x minus 2. So the 7 is the only one that needs to get multiplied by my x minus 2. So I end up with 5x equals 7 times x minus 2 plus 10. So I go through and solve my problem. I get 5x equals 7x minus 14 plus 10. Simplify. End up with take away 7x from both sides, and I end up with x equals 2. Well, if I go back and I plug 2 into my equation, I'm going to end up with a 0 in my denominator. And so 2 is an extraneous solution, so it can't be an answer. So in this case, there are no solutions. Okay, let's try another one. We'll go through this. Notice you have to factor the first term to see what all it has in it. So if I factor an x out, I'm going to have x times x minus 2. Well, that is actually my common denominator. I'm going to go through. I end up with 10 equals 4 times x minus 2. Oops. Made a mistake there. Ten plus 4 times x minus 2 equals 5 times x. If I start distributing, solve my equation. 10 plus 4x minus 8 equals 5x. I'm going to take away my 4x from both sides. And I get 2 equals x. Well, once again, if I plug 2 back in here, it's not going to work out for me. So 2 is not a solution to this equation. Now sometimes when we work these, we're going to get multiple solutions, and we have to check them all because some of them might work and some of them might not. Let's look at this example. I have a common denominator already, so I don't have to do much with that, but I do still have to solve the equation. So I look at my numerators. X squared plus 2x plus 2 equals 2x plus 3. I'm going to set it equal to 0, so move my 2x and my 3 to the other side. Then I get x squared minus 1 equals 0. Well, this factors into x plus 1 times x minus 1, which means x is going to equal either 1 or negative 1. Well, if we look at our function, if x is 1, it's going to make my denominator 0, so that can't be my answer. So x can only equal negative 1. You have to check all of your solutions to make sure you rule out any that are extraneous. Here we have a rather